Dear students, today we'll see the fifth part on the multiple choice questions on semiconductor electronics, which will be useful for competitive exams like JEE, NEET, CET. So let's start with the first question of the fifth part, question number 41. In the circuit shown, A and B represents two inputs. So here A and B are the inputs and C represents the output. So if you see here, A and B are the two inputs. So here we can see input A, this is input A, and this is input B. We are having diode D1 here and diode D2 here, and the output is taken as C over here. And there is a resistance here which will develop a voltage for the output C. Now here, for the inputs, we can have a combinations like when both the inputs are 0, 0, what will happen for the output C? When both the inputs are 0, 1, what will happen for the output C? When both the inputs are 1, 0, what is the output C? And when both the inputs are 1, 1, what is the output C? So let's take the first case when both the inputs are 0, 0. So if you say A is 0 and B is 0, when you say logic 0, that means it is electrically 0 volt. This is 0 volt and this is also 0 volt. Now in that case, diode D1 and D2 will not conduct. There will be no flow of current through D1 and D2. Therefore, output also you will not get any current flow in this output line over here. There will be no current flow. Therefore, no voltage will be developed across R. So in that case, C also will be of 0 volt. This will be also of 0 volts. Then that you can take it as logic 0. So here, when both the inputs are 0, 0, output C is 0. Now, when both the inputs are of a combination of 0 and 1, say this is 0 and this is 1. So this 0 for A is 0 volt and this 1, logic 1 for B is 5 volt. So electrically it is 5 volt. Now when it is 5 volt, that means diode D2 will conduct. This will conduct, whereas D1 will not conduct. So the current will flow through here, current will flow here, and therefore current is going to flow here, and that will develop a voltage across R which will be of 5 volt, and in that case C will be taken as 5 volt. That is nothing but logic 1. So this is 5 volt, this is nothing but logic 1, that is logically high. So when the inputs are 0, 1, the output is 1. Then we'll take the third combination when the input is 1, 0. So A is 1 and B is 0. A is 1 means it is 5 volt and B is 0 means 0 volt. When this is 5 volt, the diode D1 is going to conduct and D2 will not conduct because the input is 0 volt. So anyhow, this current is going to flow here and this current will make a voltage developed across R, and again in that case the output will be of 5 volt. It is nothing but logic 1. So here for this case also it is logic 1. When the inputs are 1, 1, the last combination, when the inputs are 1, 1, this is also 5 volt, this is also 5 volt. In that case, both the diodes are going to conduct. D1 also will conduct, D2 also will conduct. There will be a current flow at the output. That output will develop a voltage of 5 volt, and that is nothing but again your logic 1. Okay, so in that case also it is logic 1. Now if you see this combinations of inputs and outputs, which is called as a truth table. So when the input is 0, 0, output is 0. When the input is 0, 1, output is 1. When the input is 1, 0, output is 1. And when the input is 1, 1, output is 1. That means the input is low when both the, that means the output C is low when both the inputs are low. And the output C is high when one of the input is high or both the inputs are high. Now if you see this definition is for OR gate. This definition is for OR gate, and therefore out of these 4 options, the option 4th will be the right answer, that is OR gate. So here you can see option 4, OR gate, is the right answer. Then we'll go to the next question, question number 42. For the given combination of gates, if the logic states of inputs A, B, C are as follows. So A is equal to B is equal to C is equal to 0 is one state, and in the second state, A is equal to B is equal to 1 and C is equal to 0. Then the logic states of output D is what? So here we have 3 inputs. We have input A, input B, input C, and we have output D. Okay, so now if these inputs in the first case, if A is equal to B is equal to C is equal to 0, if they are 0, 0, 0, then what is the output D? Now here if you see, this A is 0 and B is 0. Now here you are having an OR gate. Here you are having an OR gate. So for OR gate, we know the definition as when both the inputs are 0, 0, the output is 0. And in the first combination, we have also taken as A is equal to B is equal to C is equal to 0. So C is 0. So this 0 also will come here. And this 0 will come here. So when the inputs are 0, 0, this is a NAND gate here. So we know that for NAND gate, when both the inputs are 0, 0, the output is 1. So in this case, D is 1. Okay. Now in the second combination, what we have is A is equal to B is equal to 1. So this is 1, 1 and C is 0. Then what will be the output? Now here you can take this as 1, 1. So this is 1, this is 1. For when both the inputs are high, 1, 1, the output of OR gate is 1. Now this one will be coming here. So, and C is 0 in the second case also. So 1 into 0 is 0, and when the inputs are 1 and 0, the output of NAND gate is 1. So here also the output will be 1. Okay. So we are having a combination of output as 1, 1, and this combination is shown in option 4 over here. That is 1, 1. Okay. So option 4 will be the right answer here. So here you can see option 4, 1, 1. So both the combinations of inputs when A is equal to B is equal to C is equal to 0 will also give output as 1. And if the combination of the input is A is equal to B is equal to 1 and C is equal to 0, in that case also output will be 1. Okay. Then we'll go to the next question. Question number 43. The circuit diagram shown here corresponds to which logic gate? Now, if you see this circuit diagram, we are having this as two inputs over here, input A and input B. So this is a switch for input A, this is a switch for input B. So there are two inputs A and B. Okay, and here you can see a LED. So this is the LED, and this LED will take it as output Y. This LED will take it as output Y. Now here is a 5 volt plus 5 volt supply given, and this 5 volt supply will make a current to flow like this. So there is a current going to flow like this. Now this flow of current depends upon the position of this switches, switch here for A and switch here for B. Okay. Now we will take, when the switch is open, we'll take it as logic 0. When the switch is closed, we'll take it as logic 1. Okay. So when the switches are open, what will happen? That is both the inputs where we can take it as logic 0. Now this switch also is open for A and this switch also is open for B. Okay, now when these switches are open, the current will not flow in this case. The current is going to flow here, and again here it is not going to flow. So it is going to flow here, and in that case this LED will glow. This LED will glow. That means when the LED is glow, we can take it as logic 1. When LED glows, we can take it as logic 1. When LED does not glow, when it is off, we can take it as logic 0. Now in this case, in the first case, when both the inputs are 0, 0, that is the switches are open, the LED will glow and this current will pass through this and it will go to the ground. So the circuit is complete. LED is glowing when both the switches are open. So output is 1. Output is 1. Then we'll take the second combination of the input when A is 0 and B is 1. That means A is open and this switch of the B will be closed. This will be closed. That means this current which is coming here, that can pass through this low resistance path and go to the ground. So there is no need for the current to go through the LED. So LED will be off in that case because you are giving a path for the current to go through the second switch, that is switch B. Okay. Now in that case, when the LED is not glowing, the output will be 0. Now third case, if you take A is 1 and B is 0, now in that case you are going to close this switch, that is A switch, and the current will pass through this switch and it will go to the ground, and therefore no current will pass through the LED. So output will not be there, it will not glow, so output is 0. Then fourth combination, if you take 1 1, both the switches are closed, the current is having chance to go from here also, the current is having chance to go from switch B also. In that case, the LED will not glow, so output again will be 0. So here you can see output is 0. Now if you see this combination of inputs and outputs, which is the truth table, and this truth table is for a gate called as NOR gate. NOR gate. Okay, so when both the inputs are low, the output is high. Otherwise, if any one of the input is high or both the inputs are high, the output is low. So this is NOR gate. So here option 2 will be the correct answer. So here you can see NOR gate, option 2 is the right answer. Then we'll go to the next question, question number 44. For a p-type semiconductor, which of the following statement is true? Now, if you remember a p-type semiconductor, okay. Now, in p-type semiconductor, you can see that the majority charge carriers, if you draw a p-type semiconductor, the majority charge carriers in p-type semiconductor, as we have seen earlier, will be holes. So holes are majority charge carriers, which are formed because of doping. Doping is nothing but adding of impurity to the pure semiconductor. And which impurity you are going to add? So to make formation of holes, we add impurity which are called as trivalent, which has 3 valence electrons. Okay, so with this concept, we can answer this question. For a p-type semiconductor, which of the following statement is true? The option 1 says electrons are majority charge carriers and trivalent atoms are the dopants. So electrons are not majority charge carriers, holes are majority charge carriers. So this option is wrong. Second option says that holes are majority charge carriers and trivalent atoms are the dopants. So this is correct. Holes are majority charge carriers and trivalent atoms are the dopants. So option 2 is correct. Third option, if you see, holes are majority charge carriers and pentavalent atoms are dopants. So this is wrong. It is not pentavalent atom. It is trivalent. If you see fourth, electrons are majority charge carriers. This is wrong. Electrons are not majority charge carriers. So here option 4 also is wrong. So here if you see all the options, second option is the correct option, which says that holes are majority charge carriers and trivalent atoms are the dopants. So here you can see option 2 is the correct answer. Then we'll go to the next question, question number 45. The correct Boolean operation represented by the circuit diagram drawn is. That means this circuit diagram, what is drawn, represents which gate, whether it is AND gate, OR gate, NAND gate, or NOR gate. So again here we will see the combinations of both the inputs A and B and what will be the output Y. Okay, so here you can see this is input A, this is input B, and here you are having LED, which is going to be your output Y. If LED glows, it is taken as logic 1. If LED is off, it is taken as logic 0. Okay, now here you are going to apply a voltage plus 5 volt. Current is going to flow here. And here we will see this switch of A and this switch of B. If the switch is open, it is taken as logic 0. If the switch is closed, it is taken as logic 1. Even here, when the switch is open, it is taken as logic 0. When the switch is closed, it is taken as logic 1. Now, when you apply this voltage, okay, and when both the switches are open, we will take it as logic 0, 0. So switch A is 0, switch B is 0. What will be the output? Now here, if you see this current which is going to flow here, when these switches are open, it is not going to flow here, and therefore the current is going to flow from here, this LED, and then the current can go direct to the ground. So this LED will glow when both the inputs are 0, 0, the output is 1. Okay. Now in the second case, if you take it as 0, 1, that means the first switch is open and the second switch is closed. Now in that case, if you see this current which is going to come here, now this current will not pass through this because this is open, so it will not pass here. It will go here through the LED, and this is closed. That will make no difference because this is going to go to the ground. The circuit is complete. The LED will glow, so the output will be 1. Okay, so if you take the third case, 1, 0, 1, 0, That means the first switch will be closed, this will be closed, this will be open. So the current will pass from here, but it cannot pass here. It cannot pass here. That means current is going to pass from here only. LED will glow and again the output will be 1. When the inputs are 1 1, when the inputs are 1 1, this switch, the first switch will be closed, second switch will be closed. So the current from here will pass like this, it will come here, it will pass like this, and it will go to the ground. So that means there is no requirement for the current to go to the resistive path of the LED. It will take the low resistance path of switch A and B and will go to the ground. So in that case, there will be no current flowing here and LED will be off. Okay, so in this case, you can see this LED will be off. Now this truth table is for which gate? When both the inputs are low, the output is 1. When both the inputs are 0, 1, the output is 1. When both the inputs are 1, 0, the output is 1. And when both the inputs are high, the output is low. Okay. Now this input, this truth table is going to give you the combination of NAND gate. Is going to give you the combination of for NAND gate. So this truth table, if you see, this is a combination for NAND gate. So here you can see option 3, NAND is the correct answer. Then we'll go to the next question, question number 46. In a combination of the following gates, the output Y can be written in terms of inputs A and B as what? So if you see this circuit, these are the two inputs A and B. So here A is coming as it is, and here because of this NOT gate, the input A will become as A bar. Even here if you see, here the input B will become as B bar. Input B will become as B bar. Now here if you see, this is A. Again you are having a NOT gate here. Here the input A will become A bar. And here if you see B, this B is as it is. Okay, and here you are having AND gates, AND gate, and here also you are having AND gate. So here the input is A and B bar. So for AND gate, the output will be A into B bar. Okay, and here if you see input A bar and B, so for AND gate, the output will be A bar into B. Okay, now this is an input for the next gate, which is the OR gate, and this is the input for the OR gate. So this is your OR gate, and the two inputs are A into B bar here and A bar into B here. So these two inputs will be added by the OR gate. So if you see the ORing operation here, the output will be the first input A into B bar plus A bar into B. This will be your Y. Okay, now this combination is given in the second option here. It is A into B bar plus A bar B. Okay, so option 2 is the right answer here. So here you can see option 2 is the right answer. Then we'll go to the next question, question number 47. Which one of the following represents forward bias diode? Now when we see forward bias, when we have to say that the diode is forward bias, then one basic condition required is, if you take a diode like this is the anode of the diode, this is the cathode of the diode. The voltage at the anode, that is the potential at the anode, should be greater than the potential at the cathode. Should be or greater than the potential at the cathode. That is VA should be greater than VK. Okay. So this is the basic thing what you can see in this question. You always see whether anode voltage is more than the cathode voltage. And if that is there, then the diode is forward biased. So if you see the first combination, the anode voltage, this is your anode, this is cathode in all the cases. Anode voltage is 0 volt and cathode voltage is minus 2 volt. Okay. Now in this case, it is forward biased. In this case, it is forward biased because anode voltage is greater than cathode voltage. So this is your forward bias condition. If you see the second option, this is minus 4 volt for the anode and there is minus 3 volt at the cathode. So here cathode voltage is more than anode voltage. This is reverse bias. Now if you see this, it is minus 2 volt at the anode and at the cathode it is plus 2 volt. So cathode voltage is more. So this is again reverse bias. If you see the third one, this is 3 volt at the anode and at the cathode it is 5 volt. So again the anode voltage is less than the cathode voltage. This is reverse bias. So the first option is the correct answer, that is forward bias. That is anode voltage is 0 volt and the cathode is minus 2 volt. So here you can see option A, that is the first option. Option 1 is the right answer. Then we'll go to the next question. Question of 48. The given electrical network is equivalent to what? Now here if you see this electrical network, A and B are the inputs. A and B are the inputs. And here you are having a NOR gate. Here you are having a NOR gate. So in case of NOR gate, the output here will be A plus B the whole bar. Okay. Then again you are having a NOR gate over here, and here the input of the NOR gate is shorted here. Both the inputs are shorted, and this A plus B whole bar will be the input. So this is going to act as NOT gate, and the output here will be again A plus B. A plus B. Again, this input you are going to give for a NOT gate, and NOT gate is going to complement that again. So again, this complementary here output will be A plus B whole bar. So Y is equal to A plus B whole bar. Now A plus B whole bar is the expression for NOR gate. So here option 3 will be the right answer, that is NOR gate. So here you can see option 3 is the right answer. Then we'll go to the next question, question number 49. What is the output Y in the following circuit when all the three inputs A, B, C are first 0 and then they are 1? So what will be the output when A, B, C are 0, 0, 0? What will be the output Y? And what will be the output Y when all these three inputs are 1, 1, 1? What will be the output Y? So first we'll take when all the three inputs are 0, 0, 0. So if you take these three inputs 0, 0, 0. So here you are having AND gate first. So this 0 into 0 will be 0 at the output of AND gate. And this 0 is going to come here. Here you are having a NAND gate. So this is 0, this is 0. 0 into 0 is 0. And 0, 0, if the inputs are 0, 0, the output of NAND gate is 1. So here Y will be 1 in the first case. When all the three inputs are 0, 0, 0. When all the three inputs are 1, 1, 1, what will happen? 1, 1, 1. So this will be 1, this will be 1. 1 into 1 is 1, the output of AND gate will be 1. Again, this 1 is going to come here. So this will be 1 and this will be 1. So 1 into 1 is 1 and the output of NAND gate will be 0 in that case. So output of NAND gate will be 0. So in this case, the output of NAND gate will be 0. So the options of the outputs are 1 and 0. So here you can see it is 1 and 0. So option 3 will be the right answer, that is 1, 0. So here you can see option 3 is the right answer. Then we'll go to the next question, question number 50. To get output 1 for the following circuit, the correct choice for the input is what? What is the correct choice for the input? Now here we see inputs are A, B and C. And here you are having a OR gate. Here you are having a AND gate. And this is the output Y. So Y will be equal to 1 for which of the combination? So let's see the options and we'll see the combinations in the option. The first option says that A is equal to 1, B is equal to 1 and C is equal to 0. So A is equal to 1, B is equal to 1 and C is equal to 0. So 1, 1, the output here will be 1, okay, because of OR gate. When both the inputs are high, the output is high, and C is 0. So 1 into 0 is 0 and the output here will be 0 for AND gate. So first option is not going to work, where the output is not coming as 1. If you see the second option, A and B, okay, A is equal to 1, B is equal to 0. Now 1 into 0 is, means 1 plus 0 is 1. So again, you're going to get 1 here. But here C is 0 only. Let anything come at this. C is 0 only. So if you multiply this by 0, 0, so output here will be 0. So that means the logic says that whenever C is 0, the output will be 0 only. When C is 0, output will be 0. So option 3 also will goes off. Now interesting will be option 4. If you see option 4, A is 1, B is 0. So when A is 1, B is 0, 1 plus 0, so output will be 1 here for OR gate, output will be 1. And then in the last option, C is also 1. When 1 into 1, if you take, the AND gate output is 1. That means option 4 is going to work because C is 1. Okay, whenever C is 0, because we are having AND gate at the end, and if any one of the input is 0, the output of the AND gate will be 0. That means all these options will go. All these options will not give you the output as 1. They will give output as 0 only. Now, only this option is going to give output as 1 when C is equal to 1. So, option 4 is the right answer here. A is equal to 1, B is equal to 0, and C is equal to 1. So, here you can see option 4 is the right answer. Okay. Thank you, students.